Our customer brought in this Samsung power supply board for a TV 75-inch. Yeah, the part number is a PN44-00874C or D. L75E7NR. Yeah, the customer broke the backlight connector, the lock, but that's not a big deal over there. It's still gonna connect fine. The customer, he said TV has no power, so he want me to check and repair the power supply. Quick check on the board, we see a little smoke over there. The customer was looking for any burnet or component, and he didn't see that. So, oh yeah, it's this capacitor. You can see there is a crack in this capacitor. So this capacitor gets shorted and burn it. Usually it burn these two MOSFETs. Let's go with the fuse. Alright, the fuse is open. That's the first thing. And this one, it has two rectifier bridge. This in a rectifier bridge in a regular board is not the same as the board that has two rectifier bridge. In the regular board, we can check the short between the input, the two middle pin, then we check the short in the output. But in these two rectifier bridge, they are connected different. The two middle pin is connected together. There is a big trace here, and two here together. But from here to here, that's the input. No short in the input, and should be this is the output. And we have a short here. Alright, this one connects to this one. Let's see the MOSFETs. We have two MOSFETs in the input here. No short between these two pins. There is a short here. And there is a short here. And there is a short here. So that's the first thing we need to do is removing these two MOSFETs, and we check the short again. Hopefully the switch in IC, this IC here is still good. This MOSFET is in the output. This is for the backlight. This one for the 12 volt. We have another MOSFET right here. This is for the step up voltage from 160 to 390. I'll let this down. Yeah, no short. Alright, so we have the short in these two MOSFETs. Usually the rectifier bridge, they don't go bad, but we're still going to need to check them after we remove this MOSFET. Right, then I need to remove that this one here. So do we still have any short? Nope. And let's remove the fuse. Okay, let's test these two MOSFETs. That's what removed. Alright, this MOSFET is still good, so I can be using it. Yep, this MOSFET is bad. All the legs shorted. Yep, that's capacitor tested as a resistor, and you can see there is a crack in it. So I have this MOSFET, it's the same specs. 6CR 190 Q or P. Both of them is the same 600 volt and 20 amp. Yep, this one is good as well. The fuse. Yep, the fuse is good. 0.06 ohm. And the ceramic capacitor. Yep, 100 picofarad. So that's the bad parts, and that's the good part we are going to replace. Yeah, I will install the capacitor, I will install the fuse, and I want to check in the gauge of these MOSFETs if we have the wave or is the IC is dead. So in the fuse we can just put a jumper. This is just a test. Yeah, I jumped the fuse and connected the board to the power, and let's check if we have the wave. So we are going to connect the negative probe of the oscilloscope to the negative side of the capacitor, or the black probe, this one here. And this is a big trace, that's the source. Right here. And we have a big trace right here, that's the drain. And we have a small trace going to this component, that's the gate. Yep, we have the wave. You can see it in the oscilloscope. And the other side as well, we have a small trace here, that's the gauge. And we have the wave, the switching wave. The voltage and the B capacitors, we have 150 volt. Alright, so we have the wave fine, it means the switching IC is still good. Now I'm going to need to discharge the B capacitor, then installed the two MOSFETs and installed the fuse. Then we do the test for the 390 volt and the big capacitor, and we check for the 12 volt output, plus we check for the backlight voltage. So we can use a solder iron to discharge the big capacitors. Let's measure the voltage in the capacitors. Yep. Yep, less than 1 volt. That's good. I want to check the diode too next to the burned capacitor. Zero 0.3. Open. Open. 0.3. And these two are connected. So we have this one is go to here. There could be these two pins here. It tested like shorted, because these two coils here, because this trace is go to here, it's go to here, it's go to here, and this go to this part. This one, it's go to here, then it's go to here, and it's go to here. And these two, it tested like that. Yeah. Now I'm gonna empty the pads over there so I can test it. I can just empty one pad. That will be enough. I want to be sure that diode's still good. Alright, yeah, I empty the solder around that pad, no connection to where it was. Yeah, no connection in these two pads between this pad and the diode, because now this pen is not connected to the board anymore. Like, see here, I'm touching the pen and I'm touching the trace, no connection. So yeah, the diode is good, no short in the diode. Already unplugged, just I left that cord over there. One, two, three. It's plugged. Yeah, nothing happened. Alright, that's good. And let's go to the voltage in the big capacitors. 390. It works. Okay. The voltage in the standby right here, 12 volt. It's good. You can see mark standby over there. Okay, between this channel and this channel, we have 300 volt, we have the backlight voltage. But we have the voltage for the backlight, we have the standby voltage, or basically no, we have the on voltage, because the on voltage is at 11.8. Standby voltage is a 7.5. We have 12 volt over there. Yep, the board is fixed. So this all for this video, and see you again.